Hello students, welcome to aimsindia online classes. This is a chemistry session. Here we are discussing about chemical bonding. In this session we are going to say about properties of ionic compounds. In the earlier session we have seen what is an ionic bond, how it is formed, between which elements it is being formed we have seen. Now let us see the properties of these ionic compounds. So before going to say about the properties of ionic compounds, let us see the conditions which are favorable for the formation of an ionic formation. Okay, the conditions which are favorable for the formation of an ionic compound. During ionic bond formation, the donor atom in the sense, the atom which gives electrons, which donates electrons, gets converted into a positive ion that we call as cation, isn't it? And the acceptor means the atom which is taking electrons. That atom will be converted into a negative ion or anion. So, for a strong ionic bond formation, let us see here how the donor and acceptor atoms should behave. Okay, so what are the properties to be there for donors and acceptors to form a strong ionic bond? Okay, what are our donors and acceptors here? We know ionic bond is formed when atoms transfer electrons from one to another. When one or more electrons are transferred between two atoms, then there occurs some force of attraction between those oppositely charged ions formed. That we are calling as ionic bond. There, the atom which is releasing or giving electrons is called donor atom that converts into cation, isn't it? And the atom which is accepting these electrons is called acceptor, and that converts into anion after accepting electrons. So, what should be the properties for these two cations and anions so that the strong ionic bond will be found between them? Now, let us see those behavior here. First, let us see the features of donor atoms. That means the features of the atoms which are giving electrons. Donor atoms lose electrons with greater ease if the following conditions are satisfied by them. One among them is less ionization energy or less ionization potential. If ionization potential is less for an atom, then less energy is required to remove the electron. What is meant by ionization potential here? We know the minimum amount of energy required to remove an electron from the atom, isn't it? Of course, definition is different here. Just simply to say energy required to remove the electron from an atom. If the ionization energy is less for an atom, then then that atom can release electrons easily, isn't it? Hence, the electrons can be lost easily by the donor atom if it is having lower ionization potential. Okay. Second property to be there for donor atoms is more size. If the size is more, then the nuclear pull on the outer electrons will be less, isn't it? Therefore, electrons can be lost by the donor atom very easily. If size is bigger, nuclear force of attraction on the outer electrons will be less because distance between these will be greater. So, as nuclear force is less on the outer electrons, then those can be removed or can be released by the atom very easily. So, if the size is greater, that can form easily a cation. That means that can form strong ionic compound. And even in terms of ionization potential, if you say the atom with a lower ionization potential will form strong ionic compound. Okay, because that can lose electrons very easily. Next property, that is less cation charge. The charge on the cation should be less. A cation with more charge is more difficult to be formed. For example, the formation of Ca plus 2 occurs in two steps. Ca plus 2 means cation of calcium. This will be occurred in two steps. First step is formation of calcium ion. That is, when calcium atom loses one electron, it forms calcium ion, Ca plus ion. The second step, what happens? Calcium plus ion formed already will lose one more electron and form Ca plus 2 ion. Okay, in this way, in two steps, Ca plus 2 ion is formed. First, one electron is lost by calcium and then the second electron. The extra charge on Ca plus results in extra nuclear pull. This makes the removal of second electron from Ca plus more difficult, isn't it? What happens? First, calcium losing one electron and forming Ca plus ion. By this, nuclear charge is greater for this than the number of electrons charge, isn't it? It has 20 protons, but number of electrons 19 only. So what happened? Nuclear charge is much greater here than the electrons charge. So they will be held tightly by the nucleus. Now the removal of second electron will be a little difficult and requires more amount of energy. So if it is cations are having less energy, then they can form easily ionic compounds. Okay. Next, let us see the features of acceptor atoms. Acceptor means the atoms which are accepting electrons from the donors in the formation of ionic bond. So, how the acceptor atom should be to form a strong ionic bond? Let us see here. First among them is acceptor atoms gain electrons more easily in the if they have the following conditions. Let us see first condition here: high electron affinity and electronegativity. What is electron affinity? The amount of energy released by an atom while taking an electron or while gaining an electron. The atom which is very ready to gain electron, that can release more energy. So the atoms which are having greater electron affinity, they can accept electrons very easily. Simply to say, isn't it? Right. In the same way, electronegativity means the tendency of an atom to attract the electrons towards it in the covalent bond in the bonded atom molecule. So that this tendency also will help the atom to be much good acceptor. Okay, now let us see here. If electron affinity and electronegativity are more for an acceptor atom, then the atom has greater tendency to gain electrons. More energy is released when an electron is gained by it, resuming in greater stability of the acceptor atom. Okay, the atoms which are having greater electron affinity and electronegativity, those atoms can attract electrons very easily towards them, and even they can release more amount of energy while taking those electrons. And hence, what happens? They will go into least energetic state, and hence they become more stable by accepting those electrons. Okay. In that way, the atoms which are having greater electron affinity and electronegativity can accept electrons easily and they form strong ionic bonds. Next property of acceptors is a lesser size. We told for cations to be formed, they should have greater size because there the distance between the nucleus and the outermost electrons will be greater and hence they can release electrons easily and they form cations. But in the case of anions or acceptors, the size should be smaller. When the size of the atom is small, the nuclear pull on the electrons is more. Therefore, electrons can be gained easily by that atom. Okay, as it is to accept the electrons, the distance between the nucleus and the outermost orbit, if it is very less, then what happens? That atom can attract the electrons very easily towards it and hence form anion very easily. Okay, this is one of the property to be there for acceptor atoms to form strong ionic bond. Next property, less anion charge. It is similar to that of less cation charge. Here also, anions also should have smaller charge, then they can form strong ionic bonds. So if they have less charge, it is easy to form there. The charge on anion should be less. An anion with more charge is difficult to form. Let us say, for example, the formation of O2 minus ion. This occurs two steps. Formation of oxide ion form occurs in two steps. First, oxygen will gain one electron. By gaining one electron, it forms O minus ion. And then this O minus ion will gain one more electron to form O2 minus ion. So here what is happening? The extra negative charge on the O minus results in the repulsion of the second electron that is added to it. Isn't it? So after gaining one electron, what is happening for the oxygen? It is having extra negative charge than the regular. So than the nuclear charge, negative charge is more in this atom. Then the acceptance of second electron becomes a little difficult for the oxygen. So to overcome this repulsion, additional energy is required by the oxygen atom to accept the second electron, thus making it more difficult for O minus to gain an additional electron. So formation of O2 minus is more difficult than the formation of O minus ion. Okay. Thus, based on these properties, first A and second A group elements get along well each other, forming strong ionic. Okay, sorry, here they are given first first A group elements and seventh A group elements get well with each other, forming strong ionic bond. What did you say? Features of the donor atoms? They should have least ionization energy, and they have greater size, lower charge, isn't it? If these all properties are there, that can form a donor very easily or cation very easily. These all properties are there for alkali metals or first year group elements. What are those? Lithium, sodium, potassium, rubidium, cesium. These elements are having, they will be having less cation charge and a greater size. We know in a period alkali metal is the atom with the greater size, isn't it? And even they have least ionization energy in all the periods. So as these all properties are there for these alkali metals, they can form cations very easily. So when they participate in the bond formation, they form strong ionic bonds. At the same way, if you observe for seventh year group elements, all the properties whatever you have said for these acceptors, all are there for these seventh year group elements. What are those? Small size and even greater electronegativity and electron affinity and a small charge, small anion charge. These all properties are there for seventh A group elements. And hence, when these two combine, first A group elements and seventh A group elements, they can form strong ionic compounds because they can easily release electrons and these can accept electrons very easily. And hence, strong bond will be formed between these two. Okay. For example, if you say sodium chloride, it is an ionic compound formed between first A group element sodium and seventh A group element chlorine. So these two will formed here an ionic compound which is a strong ionic compound. If we see potassium fluoride is also in the same way. Lithium fluoride. These are examples for the strong ionic compounds. Okay. First A and seventh A group elements form strong ionic compounds. Next. Now let us see here the properties of these ionic compounds. Let us see first about physical state. Generally, electrovalent compounds are hard solids in nature. The hardness is due to strong forces of attraction between oppositely charged ions which keep them in their allotted positions with tight bondings. For example, if you see one of the ionic compounds, rock salt. This is rock salt, is it? So this is we know as it is a hard solid. Like this, all ionic compounds are hard solids. This is because of the tight binding of oppositely charged ions because of force of attractions. Okay, and these ionic compounds are hard solids but brittle in nature. What is the meaning of this brittleness or brittle nature? Even though they are hard solids, when they are beaten or when they fall down, they break into small pieces very easily. That breaking into small pieces very easily is called brittleness. Ionic compounds are hard solids, but they are brittle in nature. So the brittleness of these crystals, ionic crystals, is due to the moment of a layer of crystal on the other layer by application of external force when like ions come in front of each other. See, this is for example, if we see sodium chloride in the form of rock salt, just now we told rock salt is a hard solid because their oppositely charged ions are tightly held with other ions. So because of that, it will be very strong solid or hard solid. When it is beaten, with a certain external force is applied, then these ions will be dislocated. Then like ions will come in front of each other. Then what happens? The force of repulsion come into play. Now what happens between these two? Repulsion occurs as they are same kind of ions. So because of repulsion, what happens now? The breaking of crystal occurs on account of these forces of repulsion. Immediately, the hard solid will be broken here into pieces because when it is beaten or when certain external force is applied, the pattern of the ions in the ionic compound will be disturbed, and the same ions or the ions the same charge may come side by side or in front of one another. Then immediately, as they have same charge, repulsion occurs between them. Yes, when repulsion occurs, they will be separated and they become apart each other, and hence the ionic sword will be broken. So when it is fallen down, when ionic crystals are fallen down, or when we beat with an object, immediately they break into small pieces because of this reason. This behavior or property of the ionic compounds is called brittleness. That's why we say ionic compounds are hard solids but brittle in nature. Okay. Next, melting and boiling points of ionic compounds. Ionic compounds possess high melting and boiling points because they are strongly held with opposite ions. So breaking of this force of attractions requires large heat energy. Let us see here reason also. Melting and boiling points of ionic compounds involves breaking of the lattice structure and setting the ions free. So for making these ions free, it requires a large heat energy. In a lattice, that means in the crystal, in a lattice, there are strong electrostatic forces between the oppositely charged ions. To break these strong electrostatic forces, considerable amount of energy is required. Hence, the melting and boiling points of ionic compounds are very high. Got it? Next point. Next property is solubility. Ionic compounds are soluble in water. They are fairly soluble into water. We know one of the examples for these ionic compounds, sodium chloride or common salt. We know common salt is very fairly soluble into water. What is the reason for this? Dissolving an ionic solid involved the setting of opposite ions free from lattice into the solvent. This can happen when the strong electrostatic force of attraction between the opposite ions is weakened. Therefore, solvents having oppositely charged ions, called polar solvents, should be used. The best polar solvent is water. Therefore, almost all ionic compounds are soluble into water. So, what is a necessity for being soluble into a liquid? So, for ionic compounds, the oppositely charged ions should be separated. The electrostatic forces should be weakened between the opposite ions. Then only they will be separated into respective ions. Then they will be soluble into that liquid. So this happens when these ionic compounds are dissolved into the solvent which is having opposite charged ions or polar charged particles. One of the best polar solvent is water. because in water molecule oxygen combined with two hydrogen atoms, isn't it? Even though it is a bond formed by sharing of electrons between oxygen and hydrogen, there will be more electronegativity of oxygen. Because of that, slight charges will be found, which we are going to learn in the coming classes. No worry. Okay, that's why it is called polar solvent. So ionic compounds are fairly soluble in polar solvents like water. That's why almost all ionic compounds are soluble in water, we can say. That's about solubility. Next property, electrical conductivity. Ionic solids consist of oppositely charged ions held together with strong electrostatic forces. So they cannot move. Hence, conductivity is not possible because in ionic solids, all the ions are held tightly with opposite charged ions with electrostatic forces between them. So there is no mobility for these ions. That's why ionic compounds are bad conductors of electricity in the solid state. However, in their fused or aqueous state, ionic compounds are good conductors of electricity due to the presence of mobile ions. So, in the fused state or aqueous state, what is meant by fused state? Molten state. If an ionic solid, if it is heated at very high temperatures, it converts into liquid form. That liquid obtained by the ionic substance is called fused ionic compound. In that state also, in that state what happens when it is converted into liquid form, the oppositely charged ions will be separated. There will be free mobility of these ions. This is called molten state or fused state. In the other way, if this ionic compound is dissolved into a polar solvent like water, immediately these ionic compound will be split into respective opposite charged ions. So there is mobility of free ions. In these two cases, ionic compounds can conduct electricity. They can be good conductors of electricity in fused state as well as in the aqueous state. But in the solid state, they are poor conductors because there is no mobility for the ions. Got it? Next one. High reactivity. Ionic compounds react instantly in fused or aqueous state. Of course, here also we say reactivity in the solid state is somewhat less. But ionic compounds react instantaneously in fused or aqueous state. This is because of easy formation of free ions. Rapid union of these ions in solutions form new compounds. Okay? Because in the aqueous state or fused state, these ionic compounds form respective ions very easily. So these ions will rapidly combine and form new compounds. Hence we say ionic reactions are very fast. They react instantaneously. Okay? See here. So formation of ions is very easy with these. Next one, directional property. A given ion in the ionic crystal is surrounded by a uniform electric field around it. Therefore, the electrostatic bonding force acts equally on the ion in all the directions. See here, if we see formation of magnesium oxide, it is an ionic compound. But single magnesium and single oxygen, they won't combine to form magnesium oxide molecule. What happens here? So many magnesium ions and so many oxide ions will be held together. Each ion will be held by number of oppositely charged ions here. If we see oxygen from this side, oxygen from this side, in this way from all the directions, oppositely charged ions will be held tightly that. So we can say it is not fixed in one direction. Ionic bonds are not fixed for one direction. They have electrostatic force from all the directions from the oppositely charged ions. That is why we say ionic bonds are non-directional. As there is no specific direction for the electrostatic bonding force, the ionic bond is said to be non-directional bond. Okay, they are said to be non-directional. There is no fixed direction for this attraction because each ion will be having attraction from all the directions from the oppositely charged ions. So we say ionic bonds are non-directional. Isomorphism. Crystals of different ionic compounds having similar arrangement of ions as well as geometry are known as isomorphs. And this phenomenon is called isomorphism. Let us see some examples here so that we can understand this. If you see zinc sulfate and iron sulfate, if you observe, there are certain water molecules also in the formula. Do you know what these salts are called with water molecules? Yes, hydrated salts. We can say this is now hydrated zinc sulfate and it is hydrated ferrous sulfate. If you observe, both are having similar arrangement of ions. Zn plus 2 ion combined with sulfate ion. Fe plus 2 ion is combined with sulfate ion. This molecule is with the 7 water molecules. This is also with the 7 water molecules. And they'll be having similar geometry also. Such kind of ionic compounds are called isomorphs. And this phenomenon is called isomorphism. Okay. The valency of elements forming isomorphs will be same. If you observe here, the valency of zinc 2 or plus 2 is same. Whereas for the iron also it is same here, plus 2 or 2. Valence is same. Okay. This is about properties of ionic compounds. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today and visit our website aimstoday.in for latest updates and recorded videos.